Hello dear students, I hope you are doing well. So in this video we shall discuss a few problems from the exercise 2.1. So let us see the first problem. It is given sine inverse of 1 by 2. That is to find the principal value of sine inverse of 1 by 2. So first let us see. The sine inverse function is defined in the interval -1 to 1. And what is its range? It is minus pi by 2 to pi by 2. And what is this? This is the principal value branch. Okay. So we need to find the principal value of sine inverse of minus pi by 2. So let us see. Let sine inverse minus pi 1 by 2 is equal to 1. Now this can be written as sine of y is equal to minus 1 by 2, and this can be written as is equal to, now what is 1 by 2? I can write what is for what degree we have sine 1 by 2, that is for pi. That means in place of this I can write sine of pi by 6. So this is equal to sine of y is equal to sine minus of pi by 6. Clear? Why? Since sine x is minus of sine x is equal to sine of minus x. Now, what is the principal value branch of sine inverse function? The principal value branch of sine inverse is minus pi by 2 to pi by 2 from here, right? And we see that minus pi by 6 belongs to minus pi by 2 to pi by 2, isn't it? You can easily see that it belongs to this, and hence we can say that this is the principal value. Therefore y is equal to minus pi by 6. Hence sine inverse of minus 1 by 2 is equal to minus pi by 6. Clear? Next we have a problem, that is cos inverse of minus 1 by 2. So we need to find the principal value of this problem. Let us see. Here let us consider cos inverse of minus 1 by 2 is equal to y. Now this implies cos of y is equal to minus 1 by 2, and this implies cos of y is equal to, in place of 1 by 2 I can write cos 60 degree, that is pi by 3. Also one thing to be remembered is that cos inverse is a function from defined on the interval minus 1 to 1 to 0 to pi. So this is the principal value branch. Yeah. So we need to find the value here. Okay. Now this can be written as is equal to cos of pi minus pi by 3. So why I have written this? See one thing. This is our 4 quadrant. Here we can see the cos is negative. So in the first quadrant all the trigonometric functions are positive. Here cos is all sine, here cos is negative, here also negative, here it is cos is positive. So if I want to make it positive, I can either bring it here or here. That means our cos is negative, so it will be either here or here. Okay. But what will be the value of minus cos pi by 3 here? So it will be somewhat, since it is 0, here it is pi, so it will be something pi minus pi by 3. And in this quadrant it will be pi plus pi by 3. Okay? But what is our principal value branch? It is from 0 to pi. And if I take this quadrant, so it will be pi plus pi by 3. That means it will be more than pi. Clear? So the value will exceed this interval. So we need to take this part. Using that, I have written in place of minus cos pi by 3, cos of pi minus pi by 3. And this implies cos y is equal to cos of 2 pi by 3. Therefore, we have y is equal to 2 pi by 3. And hence, cos inverse of minus 1 by 2 is equal to 2 pi by 3. Also, one thing to be noticed is that this 2 pi by 3 clearly belongs to the principal value branch of cos inverse. And hence, we can say that this value is the principal value of cos inverse minus 1 by 2. Clear? The next problem we have here is cot inverse minus of 1 by root 3. So let us see. Here the function cot inverse is defined on the side of real numbers, and the principal value branch is the open interval 0, pi. Okay. So how to do this? For that, let us consider cot inverse minus 1 by root 3 is equal to y, and this implies cot of y is equal to minus 1 by 3, and this implies cot y is equal to minus of cot of pi by 3, and this can be written as cot y is equal to cot of minus pi by 3. Clear? Let us keep the equation number 1 here. Now, whether this minus pi by 3 belong to the principal value branch here? Clearly, minus of pi by 3 does not belong to the open interval 0, pi. Because simply it is a negative sign. It is a negative value. So it does not belong here. So what to do? Therefore, from equation 1, I can write cot y is equal to cot of pi minus pi by 3 by STC. That is the previous one that we have done similarly. And this can be written as cot of 3 pi minus pi by 3, that is equal to cot of 2 pi by 3. Okay? So clearly 2 pi by 3 belong to the principal value branch, that is 0, pi. Therefore, what is the principal value of cot inverse? To be 2 pi by 3 is the principal value of cot inverse minus 1 by 3. Yep, easy. Next we have other problem, that is the question number 11. So here it is given tan inverse. We have to find the principal value of tan inverse 1 plus cos inverse minus half and sin inverse minus half. So let us take tan inverse 1 is equal to x. Now this can be written as tan x is equal to 1. So tan x is equal to 1. For what value we can write? For what value of tan we get 1? So it is tan of pi by 4. So this implies we can write x equal to pi by 4. Next, let us take cos inverse of minus 1 by 2 is equal to y, suppose. This implies cos of y is equal to minus 1 by 2. This implies cos of y is equal to minus cos pi by 3. And this implies, just from the previous question, if you refer to cos y is equal to, I can write here cos of pi minus pi by 3 by STC rule, and this gives us cos of y is equal to cos 2 pi by 3, and hence we get y is equal to 2 pi by 3. Fine. And next, the last one, we have sin inverse minus 1 by 2 is equal, let us take it as z. This implies sin of z is equal to minus 1 by 2, and this implies sin of z is equal to minus of sin pi by 6. And this gives us sin z is equal to sin of minus pi by 6. And this implies I can write z is equal to minus pi by 6. Also, you can check that all these values, that is x equal to pi by 4, y is equal to 2 pi by 3, and z is equal to pi by 6, all this belongs to the principal value branch of this respective inverse trigonometric functions. Okay, that means this x belongs to the principal value branch of tan inverse, this belongs to the principal value branch of cos inverse, and this z belongs to the principal value branch of sin inverse. Therefore, since I have to add this, so I can add, therefore x plus y plus z will be equal to pi by 4 plus 2 pi by 3, and here it will be minus pi by 6. So if I calculate it, it will be, so if I take the LCM, it will be 12, and so it will be 3 pi plus 4 to 8 pi minus 2 pi. Okay, and that is equal to 8 to 11 minus to 9 pi by 12, and that would give us 3 pi by 4. So that is the principal value of this problem. So I have given a few PDFs, I have given a few problems in the PDF as well, also in the PPT. So please solve them and submit the assignment as early as possible. And if you have any doubt, so please do contact me. And that will be the end of this chapter, because the major part, that is the elementary properties of inverse trigonometric functions, has been reduced. So in the next chapter we shall be coming up with matrices. Okay, so that's the end of this video, and thank you so much for watching, and stay home and stay safe.